Hi class, welcome to our next lesson, which is 7.8. What we're talking about today is we're talking about functions and their inverses. So inverse functions and inverse relations. First, let's refresh our memory on what a relation is and what a function is. A relation, very simple, it's just a set of ordered pairs. So it's x, y ordered pairs on a grid paper. So 3, 7, 2, 6, 0, 4, this is an example of a relation, just a set of ordered pairs. Now, the inverse of that relation, or the inverse relation, something we're diving into today, is it's that set of ordered pairs, but this time it's obtained by reversing the order of the coordinates of each ordered pair in a relation. So layman's terms, it's just switching around the x and the y. The x now goes to the y spot, and the y goes to the x spot. So instead of 3, 7, it's now 7, 3. Switch around 2 and 6. So 2 now goes to the y spot, and 6 now goes to the x spot. In the same way here, instead of reading 0, 4, the inverse is 4, 0. All you do is switch them around. So we have a relation, and the inverse is found by just switching around the x and y points. So let's take a look at number 1 now. Let's use this relation. Letter A says find the inverse of the relation. So what we're going to do, class, we're just going to switch around the x, y ordered pair. So here we have 1, 3. To find the inverse, it is going to be 3, 1. Pretty basic so far. 6, 3, we're going to write down 3, 6. The inverse of 6, 0 is 0, 6. And the inverse of 1, 0 is 0, 1. Hopefully everyone understands that part. All you're doing is switching around the x and the y. Let's look at letter B. Plot the points of the relation with dots and the inverse with x's. So our relation is right here, and we're supposed to graph it with dots. So let's put a dot at 1, 3, right there. Our next dot is at 6, 3. We have our third dot at 6, 0, and then our final dot at 1, 0. So all of those dots are our relation. Now it says graph the inverse with x's. So at 3, 1, we're going to put an x. 3, 1, we got an x. At 3, 6, another x. 0, 6, and now at 0, 1. So we've successfully completed step letter B. Our final one, it says for C, graph the line y equals x, and what do you notice? Graph the line y equals x. Well, y equals x is like saying y equals 1x plus 0 to put it into y equals mx plus b form. So our y-intercept is 0, and then our slope is 1. Up 1, over 1. A rise of 1 and a run of 1. Let's connect these with a straight edge. So if you don't have a straight edge, please pause the video and go get one. A ruler, the side of your planner, a flat sheet of paper, whatever the case might be, make sure you get a straight edge because you'll need it for more in this lesson as well. So there's my line, y equals x. I'll label it right here, y equals x. For future reference, we're going to graph the line y equals x several times today. The line y equals x always looks like this, where it starts at the origin and it goes up and to the right at a 45-degree angle. All right, so we've done step letter C, except for this last part where it asks the question, what do you notice? Pause the video, class, look at the dots, look at the x's, and just critically think to yourself for a second, what do you notice about these? After unpausing the video, hopefully maybe you saw this. This is a geometry term. The x's and the dots are reflections of each other. A reflection is a figure that is flipped over a line. So if you were to think about this x right here, what if we were to flip it over this line? It would be right where that circle is. I kind of draw those lines badly there. I apologize for that. This circle, this dot, and this x are the same distance away from the line y equals x. So picture just kind of flipping it. Same thing with this x and this dot. They're the same distance away from the line y equals x. Same as this one and this one and this one and this one. All four of those points are reflections of each other over the line y equals x. You can almost kind of picture it this way. Think of the grid paper as being a piece of paper, and this as being a fold. So fold it over that line y equals x. When you fold it, the x's and the dots would land right on top of each other. That is what a reflection is. It's a reflection over y equals x. We're going to see that pattern several times today. Now that we've talked about relations, let's talk about functions. A function we always call f of x. So the inverse of that function we always call f to the negative first of x. We never read it like that. It's f raised to the negative first of x. The way we read this is it is the inverse function of x. So whenever you see this, it's not f to the negative first of x. Read it as it's the inverse function of x. So to find an inverse, very similar to a relation, all you do is switch around the x and the y. And then we're going to have to solve for y. So when we have these lines, we're going to solve for y after switching the x and y variable. Now remember, whenever we read f of x, it's the same thing as writing y. When we have f of x equals mx plus b, it's just like writing y equals mx plus b. That f of x and y is the same thing. All right, let's see our first function. Our function f of x equals a negative x plus 2. Step letter A is to graph and label that function. So let's graph this one. We're used to seeing it look like this. When we see a numerator divided by a denominator of 2, take each term and divide it by that 2. So a negative 1x divided by 2 is a negative 1/2 x, and 2 divided by 2 is a positive 1. So we're used to seeing it look like this. Y equals a negative 1/2 x plus 1. A negative 1/2 x plus 1. So now let's graph this, class. Shouldn't be too difficult. We have a y-intercept of 1, and we have a slope of a negative 1/2. So down 1 over 2. Let's get out our straight edge and connect these 2 points. Now it says graph and it says label. Graph and label. So I really want to be picky on this one, class. It's very important that you label this. So label this as the function of x, or f of x. Step letter A is taken care of. Now it says find the inverse function of x. So now, class, we're going to do this part. To find the inverse function, switch x and y and solve for y. So in our function, y equals a negative 1/2 x plus 1. We're now going to switch x and y. So y you're going to put over here, and x you're going to put over here. So now we have x equals a negative 1/2 y plus 1. So we switched around x and y. In the same way we did with our relation, we do the same thing with functions. Now we solve for y. So we want to get this y all by itself. The first thing we're going to do is subtract 1. So we have x minus 1 equals a negative 1/2 y. And now we're going to multiply both sides here by a negative 2. Because a negative times a negative is a positive, and a negative and 2 times 1/2 is y all by itself. So if we multiply the right side by a negative 2, we got to multiply the left side by a negative 2. So we distribute, and we get a negative 2x plus 2. So there is our inverse function of x. So let's write that down. We're used to seeing the y on the left side. So let's write this on the left, the inverse function of x. That equals a negative 2x plus 2. Sorry, I ran out of room there. I must have wrote too big. Hopefully you could still fit that on your paper right underneath all your other work. So in step letter B, this is what we were supposed to find. The inverse function of x equals a negative 2x plus 2. All we did was switch around x and y and solve for y. Step letter C, grab and label the inverse function of x. So we're going to graph this one right here. This one has a y-intercept of a positive 2, so go up 2. And it has a slope of a negative 2, which means down 2 and over 1. Down 2 over 1. get out our straight edge and let's connect these dots. And now we must label this. This is the inverse function of x. So it says graph and label for step letter C. We've done that. Our final one, step D. Graph and label the line y equals x. We did that on the very first one. Hopefully you remember it starts at the origin and it goes at a 45 up and to the right. Same thing with down and to the left. It goes at a 45-degree angle down and to the left. And so here is our function y equals x. So on each of these I want you to label, graph and label all three lines. And on your notes it says again, what do you notice about this? What we notice is that if you were to fold your graph paper over this blue line, what happens again? F of x and the inverse function of x are inverses of each other. This would land right on top of this part if you folded the line, and this one would land right on top of this one if you folded the line. So they are complete inverses of each other. And that always happens with these inverse functions. So what do you notice? The two lines are reflections of each other. The two lines are reflections of each other. All right, we got one left. We'll see if this relationship holds true for number 3. Find and graph the inverses. We're first going to, letter A, graph and label f of x equals 4x plus 5. A y-intercept of 5, 1, 2, 3, 4, 5. And this one has a slope of 4 over 1. So if we go up 4 and over 1, that's the same thing as going left 1 and down 4. So go left 1, down 1, 2, 3, 4. And take out our straight edge and connect these 2 points. That was probably a bad line. Let me try that again. So this line is f of x. Step number B, find the inverse function of x. So we have y equals 4x plus 5. To find the inverse, we're going to change around x and y. So now x equals 4y plus 5. And now we have to solve for y. So we're going to subtract 5. X minus 5 equals 4y. And then we're going to divide by 4. So y equals 1/4 x minus 5/4. Minus 5. So we're going to rewrite that again, class, as the inverse function. So the inverse function of x equals 1/4 x minus 5/4. There's step letter B. Step letter C says graph and label the inverse function. So this one slightly more difficult to graph, but nothing we can't handle. It has a y-intercept of a negative 5/4. So go down 1 and 1/4 and put a dot. And now it has a rise of 1 and a run of 4. So up 1 over 1, 2, 3, 4. Let's take out our straight edge and connect the dots. It says graph and label, so be sure to label this. This is the inverse function of x. And then step letter D says graph and label the line y equals x. We've done this 3 or 4 times today, so we can do it again. And there we have it. Label it. This is the line y equals x. And in your notes, once again, it says, what do you notice? And the answer is hopefully the exact same. The two lines are reflections of each other. Here's the fold in the piece of paper. If you fold it over, the lines are reflected right on top of each other. So once again for step D, the two lines are reflections of each other. Think of the line y equals x as being a mirror. It's reflected over that line to the other side of it. And that will always be the case with inverse functions in relations. So our assignment is going to be on page 393. I have that in a worksheet for you. It's 20 through 28. What I want you to do, class, is I want you to graph f of x, graph the inverse function of x, and graph y equals x. So I want 3 lines on each of your graph papers for this assignment. The directions will be on there, but I just want to be very clear that I want to see all 3 of these. You should want to see all 3 of these lines too, because it's a great way to check your work. If you have the function y equals x and it looks like this, and somehow when you graph f of x, it looks like this, and f of negative x looks like this, well, you know you did it wrong, because they should be reflections over this line. So this assignment should be a very simple one to check your work on, because just looking using your eyes, they should be reflections over this red line. So you know this can't be right. You'd have to try something over again. Let me know if you have any questions when you get to class tomorrow. Hopefully this made sense to everyone, but by all means, don't feel afraid to ask me if you need any other help.